Welcome to the Exploit Research Mega Primer Part 4. In this video, we will try and exploit a real-life vulnerability in the Mini-Share program. So before we begin, a little bit of doubt clearing. A couple of you have left comments behind and asked questions about the whole bad character thing related to memcopy and strcopy. So to answer your question, memcopy does not use any character to delimit the input. And the way it is called is memcopy, location where you want to go ahead and finally store data. The input basically goes ahead and actually points to the data which you want to store into location, and length is the amount of data to copy from input into location, right? So memcopy deals with memory locations and considers them just as single bytes, and the only way it decides how many characters to copy is by the length value. It is immaterial what characters are actually there in input. In contrast, strcopy uses the null byte, which indicates end of string. The null byte, as you know, is just a byte having value 0, and it uses this to go ahead and decide how much of input to copy into location, right? So this is where having a null byte in your payload is going to go ahead and cause strcopy to truncate the input and just copy everything till before it hit the null byte. So in conclusion, there are no bad characters as far as an memcopy based buffer overflow is concerned. And in today's example, we will look at more bad characters apart from just the null bad character. So now I think we have enough theory in place. So we will look at real life vulnerabilities, and in this what we will take up is the Mini-Share program. The full description of this exploit is available on ExploitDB, and this is a vanilla buffer overflow where we will use jump ESP as we did in the previous video. However, we will need to find the bad characters for this specific program. One important difference is now we do not have any access to the source code. So let's quickly look at what the vulnerability states. If you go to this link which I mentioned in the presentation, you would actually be able to see the whole description of the vulnerability. This is quite an old vulnerability. And basically, what the discoverer has told is that this is a simple buffer overflow in the link length. And if you kind of scroll down to try and understand this code, what you would notice is we are making a get HTTP request. After get, we are actually having our entire payload, which consists of the 41s as well as probably the shell code and a couple of other things. And then we finish the HTTP request by typing in HTTP 1.1 and giving the end of HTTP header delimiters, which are /r/n/r/n. So basically the overflow is triggered by the link itself in the get request. Now what this means is that if we send a request of the form get slash, or even without the slash, a long URL, and if this URL is larger than the buffer length probably the Mini-Share program uses to store and probably parse this URL, then we're going to have a buffer overflow. So in this demonstration, we will look at how to exploit this vulnerability, right? Note, we are not doing any zero-day vulnerability discovery here because we are not trying to find the vulnerability ourselves. We have taken a vulnerability which is described in ExploitDB, and now we are looking at how to go ahead and recreate and exploit this vulnerability in our own lab, right? Finding vulnerability using fuzzing and other techniques is something we will take up in later videos. So in this case also, we will use the exact same thing which we did in the last video, which is the jump to ESP. So we will first have to figure out once we override the stack exactly how far or what is the offset of the overwrite which overwrites the return value and overwrites also the top of the stack. From that point on, we'll have our payload. We will overwrite our return value with the address pointing to a piece of code either in a Windows DLL or in a third-party DLL, which basically has the command jump ESP at that location. This will force the control or the EIP to start executing instructions from the position where ESP is pointing to, and at this place we were going to have our payload which will go ahead and then execute, right? Exact same stuff which we did in the last video. So let's do this now. You can download Minishare from the link provided on this page and start this demo. So we have our Windows machine, which is actually the vulnerable machine, which actually is going to host the vulnerable software. And then we have our Backtrack machine as usual. You logged into Backtrack into the securitytube.net directory, and we have installed the Minishare program inside the Windows XP system. So I'm running Service Pack 3 as I mentioned in previous videos. Now what we are going to do is we are going to first trigger the vulnerability. So this program is actually listening on port 80 for connections of HTTP request. Now basically you can drag and drop files and folders which would be shared by this program. But let's go ahead and trigger the vulnerability. So for this we'll have to write a simple script. Let's call it minishare.py. Just the usual stuff which we write. Right, this is going to be a stream socket. Now we are going to connect this to the remote system on which Minishare is running. First argument is the IP address which will come from user input, and then we have port 80. Then we have our actual buffer, which is first going to contain the get. Then we are going to send the arbitrarily wrong URL. Let's say we can have A probably 2000 times as usual. And then what we're going to do is we're going to finish this request by having the HTTP 1.1 and then sending out the delimiters, which is the /r/n in sequence. Awesome. Now we send this data to the vulnerable program and then close the socket. So let me go ahead and change the permission so that we can run it, and let me run the program. Before that, let's quickly find out the IP address of this system. It's 1.101. Let's go back. 192.168.1.101. Oops. Okay, I think there's a little mistake here. Well, we first have to create the variable before actually going ahead and appending it to it. Okay, now it should work. Right, we send the data. Let's go back here. And the overflow has been triggered. Let's click, and awesome. 41, 41, 41, what that means is EIP has been overwritten, right? So, and the program has crashed. So now let's go ahead and open this up in Immunity so that we can do a little bit of more advanced analysis. In this case, because we don't really care where the program is stored, well, we can just restart the program and search for it in Immunity and then go ahead and attach to it. So here is the Minishare program. It's bound to port 80. Let's attach to it. And let's go ahead and restart it. That's okay. Let's start the program. And pop, it appears, it's going to run. Now let's explore it. send the data. Just wait for a bit, and here we go. EIP has been overwritten with all 41s. ESP, which is pointing to the top of the stack, has also been overwritten with the 41s, which is ASCII value of capital A. Perfect. So now, very quickly, as we know, first thing we need to do is run pattern underscore create to create a pattern, so that we can actually figure out exactly where we are going to be overwriting the return address, as well as where we overwrite the top of the stack. Right, so we'll quickly go back here, restart the program. Get it up and running. Back to the attacker system, send the data, wait for the crash, and here we go. So EIP has been overwritten by some value and ESP has been overwritten by some value. So as you know, now we basically require the companion program. Right, which is the pattern underscore offset program. So let's run pattern underscore offset, and first let's figure out about EIP. So EIP is this value 36684,335. So it is at an offset of 1787 from the beginning of the pattern we sent, and ESP is basically pointing to this pattern CH7, CH8. Awesome. So just 4 bytes after that. And now we can verify this by looking at the stack. So if you notice, this is ESP CH7C, and just above that is basically where we overrode the return address, which contains the value 366 blah blah blah, which is nothing but 5C86. Right? So now we know the offsets. So let's go ahead and verify this by going ahead and creating a different payload. Right, I don't think we need the PPT anymore. Let's just kind of quickly remove it, probably free up some space. This is an old laptop. Okay, so let's restart the Minishare program. It's up and running. Now basically return is overwritten after 1787 and ESP 1791. So let's go back to our little program here, and what we need is, let's just remove this line, and first let's fill up the first 1787 bytes with absolute garbage. Then we fill up the next 4 bytes with 4 Bs. This is where we overwrite the return address, and now if our calculation is correct, we will be overwriting the top of the stack, and then after that let's go ahead and again pad it with a little bit of A's, maybe 300 of them. Right, now let's run this program once again. Look at what happened. Okay, perfect. EIP was overwritten with 42s, and ESP is pointing to our 4 C's followed by the A's, and on the stack this is just as beautifully shown. Right, awesome. So now all we have to do is find a return address which is going to overwrite the B's. That return address is actually going to contain an instruction jump ESP, and then after that we jump back here on the stack and start executing our final payload. Right? But before that, one important thing is to find the bad characters in the payload. So how do we do that? So let's go ahead and get the whole dump of the entire character set. Right? I've already shown you the program which I had created for this. I'll just run it to get the entire character set, and I'll go back to the exploit program and overwrite it. So what we can do is, well, let's go ahead and just add it here after the C's. right? And let's run the program again. Now, the interesting thing is the crash will still happen exactly at the same point, but what we need to look at is basically what are the values which were copied from the character set we created onto the stack, right? So let's run the program again. Let's trigger the overflow. Seems like some issue with the network connectivity. Okay, the exploit went through. We should see a crash here any minute. Perfect. So EIP has been overwritten with all 42s as expected. But after the C's, we notice that we should have actually gotten the value 0x00 at this location. But note that we are now just getting arbitrary random values. What that means is that 0x00 is actually a bad character. So this is the first bad character which we have discovered. Let's restart the program once again. Let's go back here. And now let's remove our first bad character from the list. Right, so now we are starting with 0120FF. Now let's figure out what are the bad characters. Let's send the exploit again. Again we have a crash. Let's go ahead and follow the stack to this place. Just follow it in the dump, that will be much more easier. Right? So now if you notice, after the 43s, which is basically the C's, we have 01, 02, 03, 04 going on 0B till 0C. After that we again have 0A, which means this is absolute garbage, which means 0D, which is the next expected character here, is also a bad character. Right? And that is expected because from what I remember, 0D is actually the /n. Right? We can verify that using a man ASCII very quickly. It's actually the /r, which is the carriage return. Right? Awesome. So we'll go back here and remove 0D from this list. Here it is. So now after 0C we have 0E. Now let's quickly go ahead and rerun the program. Basically, if you notice, it's basically trial and elimination to figure out what the bad characters are. Because we don't have the source code. The other way could be actually to reverse engineer the entire program and figure out what is the function it is using for the copying between the data we send and onto the buffer, etc. But that we'll probably discuss in a reverse engineering primer. Right now, we are not too much bothered about reverse engineering the entire software flow and working. What we are really looking at is how can we exploit the system. So now let's send this. There's a bit of a network lag for whatever reason. It shouldn't be because we're just running it on the same system. Okay, went through, just wait for the crash to happen. And voila, crash as expected. Now let's open up this in the dump. So now we have 43 ending here, which is all the C's. Then we have 01, 02, 03 continuing. Let's see till where it continues. If you notice, it's just increasing order. Awesome. If you notice, we were able to cover all the characters because it ended with FF, and after that we again have our 41s, which was the A which we had appended. So what this means is basically we just have two bad characters, which is the null byte 0x00 and then the carriage return, which is basically 0x0D. Right? So now we will have to create a payload which does not contain both of this. Let's run MSF payload again and look at the various module options we have. In the meantime, okay, it just loaded for once a bit fast. So what we're going to do is we're going to still go ahead and use the bind TCP. I think this is my favorite. and we'll output this in raw format and feed it to MSF encode. Now the architecture is going to be x86. The BAT characters would be, well, 0x00, 0x0d, right? And let's tell it to output in a C array format. While this is happening, let's quickly figure out where we can get the jump ESP by looking at the executable modules. Good news, we have a user 32 here, which we know has a jump ESP. So let's go here, search for it. Command jump ESP is already there from the previous demo. And here we go, we have the jump ESP instruction. And this is basically located in the address D730 9D7C, right? So let's copy the shellcode, open up the program, and at this position we're going to go ahead and feed it. And top of the stack, as discussed, we'll probably have a little nope sled here. Right, maybe 20 of them. And this is where we're going to override the return address with one from the library, which has the value D730 reverse order D730 9D7C 9D7C. Right, perfect. Notice that both the address as well as the shellcode should not contain any of the BAT characters. So the BAT characters here are 0x00 and 0x0d, and neither the return address nor the shellcode contains the BAT character. Now let's run the program. Let's restart it. Program has started running. Send the code. And if you notice, the program is continuing to run. Now, we know from experience that this is good news. So let's go ahead and verify if we have a shell in place on port 4444, which is the default port for the payload we used. Awesome. As expected, we have a shell waiting for us there. Oops. So basically, we are on the remote machine. Right? Perfect. Now let's go ahead and exit this program. So we are done. We've created a successful exploit for this vulnerability which we just read off exploit.db, right? Now one of the things which I wanted to mention is that the jump ESP instruction can actually be found practically anywhere in the program, right? So it could be many of the other modules as well which have been loaded. Some of the DLLs might be Windows DLLs, some of them might even be third-party DLLs. So you can use in either one of them. The only restriction would have to be that the address should not contain any of the BAT characters which the program uses to filter user input, right? So quick, very simple, finding the jump ESP instruction. And if you notice, there are actually multiple jump ESP instructions available in the same DLL. So the one we used when we searched for previously was located at the address 7C 9D 30 blah 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 blah. Now we are looking at the next one. Is located at some other address. Okay, so that's all for this video. In the next video we will pick up another application and try and exploit it. So I would request you to download Minishare and try this example out yourself. And like always, I really look forward to hearing about you in the comment section. Please leave your comments behind. I try my very best to read and respond to every comment. Thank you. Have a great weekend.